Well, welcome to 3.6. These are some notes that I originally gave to a CP course, but they are the same notes out of this section. Uh, this is kind of an introduction into some calculus things that we're going to do. This is a major concept that we'll deal with in Calc next year, dealing with extreme values and critical points. Essentially what this is about is being able to maximize or minimize functions. And in a real world setting, being able to find maximums and minimums is a really important aspect. In a business environment, you want to be able to maximize profits and minimize costs. If you're manufacturing something, you need to minimize vibrations in an automobile, for example. And there's a lot of things in the world that come back to this notion in the calculus of critical points and extreme values. So let's get into it and see what's going on here. What we're going to do in this section is be able to understand and talk about what extreme values are. So find extrema of functions. So, and what I mean by that is if you have some function, r of q, and so here's q, and here's r of q, this value up here. And so that point, if you look at this graph, you see that at that point, that's the highest y value that this graph obtains. And so what we're doing when we find extrema is exactly that. Is finding the largest or smallest value of a function. So, critical point, number one. What's a critical point? Well, in calculus, if I have some function, a critical point is the place where a tangent line, when drawn, would have a slope of 0, or in other words, be horizontal. So you can see as this graph goes up and then turns and then comes back down, at that point up there, there's a horizontal tangent. Likewise, down here, there's a horizontal tangent. So the critical point occurs when the graph's tangent line has no slope. And a tangent line is a line that just touches at one point. For example, over here, that's the tangent line at that point. That's not a horizontal line. It does not have a slope of 0, so that would not be, that x value there would not be a critical point. Now understand, if I ask the concept of a critical point, we're looking for a point, and a point has an x and a y coordinate. So where this critical point occurs is at -1, and the value at that point is 3. But the critical point is -1, 3, and likewise over here, the point occurs at 3. The critical value is -3, but the critical point is that whole point. So take a look at this graph, though. This is a cubed root. Now the cubed root of x is the cubed root of x looks like this. And it comes through, goes up through 0, and turns and goes that way. Understand that the cubed root of x is the inverse of y equals x cubed. X cubed looks like this, and the cubed root of x is the dotted line. Remember how there are reflections over the line y equals x. Putting a +2 inside would simply take the graph and shift it 2 units to the right. Now, we also have another part of that statement that the critical points occur where the tangent line has 0 slope, but it also is where it has no slope, or where the slope is undefined. At that split second right there, the line, the curve, is going straight up and down. The slope of the tangent line would be 0. I'm sorry, not 0, would be undefined at that point. So, at a critical point, now that you understand what that is, there can be a couple things going on. One, it could be a maximum. So if I had a graph looking like this blue line, I have a horizontal tangent, so the slope is 0, and what I have at that critical point is a maximum value. That's an extreme value. If I do any shifting around, this of course would have to have a negative out front to be an upside down parabola. It looks like it might be 3 to the right and up 2. I just made those numbers up to kind of sort of fit the graph. You could glance at this equation, though, and know that it's a parabola, know that it's upside down, and that it's going to have a maximum value. Also, at a critical point where you have a horizontal tangent line, you could have a minimum value, and if it was a right side up parabola. If you get something that looks like this, you get what's called an inflection point. It's not a maximum or a minimum, but the graph is curving upward here, and then it's curving down over here. And at this particular spot, you have an inflection point where it changes the way in which the graph curves. Now, not all inflection points are maximum or minimums, are extreme values. For example, in this graph, do you see how that point right there is an inflection point? Remember how I said it changes the way it curves? Here, this graph is curving down, and then the graph changes to curving up. Okay, thank you, gotcha. Come on. It changes to curving up. So it's curving down, then curving up. I kind of think of this side on the left is an umbrella. This side on the right is a bowl. This would not hold water, this would hold water. There's a change in the curve. That's called a point of inflection. We're not going to spend too much time talking about that in this year. We'll get to that more next year. And that's what I'm showing you here. This blue dot here is representing a point of inflection. It's not a maximum or minimum, but for a split second, there's a horizontal tangent, but there's a change in the curve of the graph. This is curving down, this is curving up. And saying the same thing. So we talk about what's called concavity. So this is concave down, this is concave up. And there's a change in y equals x cubed at that inflection point. So back to the max-min idea. This graph has a maximum, and it has what's called an absolute max, or sometimes referred to as global maximum. There is no other point on this graph that is higher than that point. It doesn't exist. It's a absolute max. You can also have an absolute min. There is no other point on this graph that's below that point. And so you've got a minimum value. You can also have what are called local or relative max or mins. This has a horizontal tangent, but there are other points that are below it. So it's not the global minimum, but it is oopsie, hold on a second. It's a relative extreme value, or sometimes referred to as a local. And local means just what it sounds like there. It's just kind of in your neighborhood. So this would be a local min, or a relative min. And now understand there's a difference between what the minimum is and where it occurs. So this is the x value. I'm going to make something up here. Let's say it occurs at -1, but the minimum value might be -4. So it occurs at -1, but the minimum value at that point is -4. The critical point would be -1, -4. So kind of give an idea of what I mean there. Both of these graphs have a critical point at 3. They both have horizontal tangents at that point. But the maximum value on F is 2, and the maximum value for G is 7. So what the maximum is and where it occurs are different things. So again, I said 4 before. I was just making up some numbers, so maybe it's 5. So the minimum value at that point would be -5. There's also a relative max at this point, at +1, and so the relative maximum value would be -1. Even though there's values higher somewhere else, there's a relative or a local min at that point. Now this graph does have an absolute minimum value. And again, I'm making up these numbers, but at 4, The lowest possible answer you will ever get is 9. There is no value anywhere else. So this graph has 2 relative or local extreme values and 1 absolute extreme value. So get your calculator out and graph this on your calculator. You can pause the video for a second and see what that looks like. Should look something like this. Now, immediately you should have recognized that it should have been an upside down parabola. That's what the negative is doing out front. And you can see that this graph is going to have, at that point, a extreme value, a critical point, and you can then use the calculator to find out what that value is. If you go into Calculate, which is above the trace button, you should be able to find the option for maximize, or just might say max. Go try that and see if you can find these values. Try that again on this one and see what you can find out. Now this is an x to the 4th power. Should have an idea about what that looks like. An x to the 4th power is going to be some kind of a W-ish looking thing. And so when you graph that, this one actually comes out looking like this. And you can see that there's going to be 3 critical points, 3 places where you have horizontal tangents. And you can find these values, again, using the Calculate button on your calculator. If you need some help figuring that out, by all means, come talk to me. So that's the idea of critical points and critical values and extreme values. They are going to be really an important aspect of a bunch of things that we're going to do next year. Got questions? By all means, come talk to me. Let me help.